Hi, I'm Manushi Majumdar, a data science product engineer with the ArcGIS Hub team, and thank you for embarking on this journey of Python for geographers with me today. While I'd love for us, honestly, to leave this session as pro Python developers, the goals of this session are actually threefold, limited to understanding how we can read Python effectively and what is really needed to get Python on our machine in order to script in Python. And then we look at ways so that we can teach Python to ourselves moving forward. Scripting in a programming language or learning a language for that matter is very similar to learning how to drive, which basically means that it's only with practice and consistency that we can get proficient and better with it. So let's try to leave this session with a way of understanding Python without feeling alienated or intimidated by the language. So the agenda for this session is as follows. We start with the bare basics needed to get started. That is the things needed to get Python on your machine. We then look at the basics for Python programming. That is the basic rules and data types needed to work with it. We look at a few open source packages that are popular in the field of data analysis and specifically GIS analysis. And we look at a cool live demo for how GIS and data analysis can be done in Python using the ArcGIS API for Python. And we'll conclude with a set of learning resources that will meet you where you're at to assist you on your journey of learning and mastering this language. So, what is Python and why really Python? Python is an object-oriented scripting language. It's a free language, which means that it's free to use, to distribute, to write scripts with. You don't need licenses at all to work with Python, unless, of course, you are developing Python on an integrated development environment, an IDE, which may require licenses. But Python as a programming language is free to work with. The syntax is extremely easy to learn, understand, adopt with very easy data structures. It's an intuitive language that helps you to pick it up easily and work with it easily. Another key benefit is it is a flexible language for building prototypes. While Python is typically used for automating quick tasks and writing scripts that perform a few steps quickly and effectively, it's also very great to develop a prototype for a particular idea, a particular project idea that you have, and to prototype it quickly and see how feasible the idea is. So Python is very easy, very flexible, very robust to build a prototype with and then test it out further. While this language has several benefits, I've laid out the three key benefits here. The first one is scalability. That is, it's very easy to start small and then build on top of it. You can start with a small, simple script, a simple program, and then expand it to one larger project or a bunch of larger, several other projects by importing those scripts, those programs, eventually as packages. The second benefit here is the integrated packages that come with a Python distribution. You may use any particular distribution, but the benefit is it comes with a large number of packages, all which are compatible with each other, which means that working with one package is not going to affect the other one. And these packages are written by several other people, which ensures that to perform a particular application, you don't need to reinvent the wheel and rewrite the whole process from scratch. These packages that come in Python distributions allow and support a large variety of applications such as database management, networking, web scraping, building web applications, web frameworks, as well as scientific computing and a lot of machine learning and artificial intelligence workflows. The third key benefit here is, since Python is a free open source language, It's built by a dedicated community of passionate Python developers that's passionate about making sure that this particular language and its distributions are up to date and are cutting edge to allow for several use cases and methods that are relevant to users as of now. To get started with Python, here is a great resource for installing Python using the Anaconda distribution. There are several distributions that you could use, like Homebrew in case you are a Mac user, an Apple user. You could even use virtual environment or pip, but Anaconda is a great distribution in case you want to use Python futuristically for data science, machine learning, or even GIS analysis workflows. As we see right here, it comes with this great suite of popular Python packages to support these workflows and to support these tasks. Installing Python through Anaconda is very easy. You follow along this link. As we see, it has detailed steps for installing Python based on your particular operating system of your machine. For example, if we look at the steps for installing it on Windows, it shows you how to fetch the installer for this particular distribution of Python, as well as detailed steps to make sure that your installation is correct and to make sure that you fetched Python correctly using Anaconda. And to verify your installation, Anaconda has also provided a few quick checkpoints that you can use to verify that you have the Anaconda distribution of Python successfully after the installation. Another key thing I'd like to make a note of here is working with virtual environments if you're working with the Anaconda distribution of Python. Virtual environments are a great technique for creating isolating working copies of Python. Let's think through an example where you're simultaneously working on a web development project, that is, you're building a web application, and a machine learning or deep learning project. Both these projects require a different set of Python packages and libraries, aside from the standard ones that come with the Anaconda distribution. So there may be a particular few niche libraries that you need to install, and you don't want the library for one task to conflict with the library of another project or another task. At this time, it's very useful and it's very handy to have several virtual environments specific to the projects you're working on. These virtual environments then help maintain specific versions of packages that do not conflict with each other and are suitable to work with that particular project and with libraries that are suitable for that use case. This is a great 2-minute tutorial for working with virtual environments and getting started with them. You start by ensuring that you have Conda installed, that is the Python distribution that comes with Anaconda. Having done that, creating a virtual environment is as easy as executing this one simple command, that is Conda create, and with your particular name, the environment name of choice. Activating your virtual environment is also very easy. You just use the activate command followed by the environment name. This ensures that in case you are previously connected to another environment, you consciously disconnect from that and connect to this one. You can then install additional Python packages to a virtual environment. So in case you're working with a machine learning project, you can then install specific Python packages within this environment that do not influence or impact other Python installations or environments on your machine. And to deactivate that particular environment, once you're done working on that project, all you do is you call the deactivate command. And once you're done with the project and you no longer wish to have that environment, you can also remove that environment, which also removes the particular dependencies and packages that you've installed within that environment. Also, In order to write scripts, you need a scripting environment. Scripting environments can be chosen based on the kind of scripts you're writing. So in case you're writing a standalone simple script, you could use a text editor such as Terminal, Notepad, Sublime, Idle. If you're working on a larger project, you could use a particular integrated development environment or IDE such as Visual Studio, PyCharm. An IDE can be thought of as a software application that comes with tools that help you write and test your scripts. They also help with syntax correction and code completion. While you most certainly can use the the text editors for scripting larger projects, an IDE is great to get up to speed on a new programming language quickly. It helps you also set breakpoints and test for your errors and learn the language more efficiently if you are an absolute beginner. You can also write your Python scripts within the Python window on ArcGIS Pro if you're working with your GIS workflows or data in your desktop GIS. My personal favorite environment for writing Python scripts though is Jupyter Notebooks or ArcGIS Notebooks that we'll be exploring as part of this particular session today. So for those of us not familiar, ArcGIS Notebooks is a new platform capability available both on ArcGIS Online and ArcGIS Enterprise that help you create new Jupyter Notebooks, new ArcGIS Notebooks hosted on the ArcGIS platform. You can also add your existing notebooks onto the ArcGIS infrastructure and work with them by hosting them on your ArcGIS Online or your WebGIS deployment. As we see here, it comes with the whole Jupyter Notebook interface integrated, and you can also work with the ArcGIS API for Python by creating a GIS object and then working with the content within your ArcGIS infrastructure. Another benefit of working with ArcGIS Notebooks is it comes pre-baked with a large number of popular Python packages or libraries. The packages or libraries support a vast variety of use cases similar to the Anaconda distribution, and it also helps you perform a large number of your spatial data science, machine learning, GIS analysis, as well as deep learning workflows. Scripting in any programming language can be thought of as basically working through a recipe. You have ingredients and then you have a set of instructions for what to do with those ingredients. Similarly, scripting in a programming language has data types for the different ways the data that you want to work with can be stored, and then instructions for what kinds of actions can be performed on those data variables or different data types. Here's a list of the most popular data types for Python. While there are a few more, this is a great list for someone to get started with to perform most of their necessary workflows. Int can be thought of as a particular data type that stores whole numbers, both positive and negative. Float stores decimal numbers, again both positive and negative. String stores words or a sequence of words or characters, again it could include numbers, as long as they're enclosed within single or double quotes. Also, Boolean is a very popular data type. While Boolean in most other languages stores value in the form of 1 or 0, Boolean as a data type in Python stores values in the form of true or false, which essentially represent the truthiness or falsehood value of a variable. Boolean is used to check or set the status of certain conditions and certain variables. List is an ordered sequence of variables stored within square brackets, as we see here. So a list in the first example, as we see, could have all the values, all the variables of a same data type, or it could also have a mix of values of different data types. Lists are normally mutable, that is you can change values of a list, you can add values to it, change existing values, or even delete values. Tuple, similar to lists, is also ordered and a tuple is stored within round brackets. Another similarity it shares with lists is you can create a tuple with similar or different data type elements within it. However, a key difference that it has from lists is a tuple is immutable. That is, you cannot change the data within a tuple once it has been declared, once it has been defined. A big advantage of this is a tuple is a great data type, a great data structure in case you want to work with write protected data. So if you want to protect a data from being intentionally or accidentally changed or modified either by yourself or someone else who is going to work through your script, you store it in a tuple. Also, since tuples are immutable, that is, you cannot really change them, they are a great data type to use for working through and for a faster process of your data, for your data to be processed faster as opposed to a list. Dictionary is an unordered collection of data, unlike list and tuple, and it stores data as a key value pair. So as we see in this example, name is the key and an is a value. Again, age is a key and 20 is its value. And to navigate a particular dictionary, you need to know its particular, to navigate a particular dictionary, you need to know its key to fetch the value associated with it. Dictionaries similar to lists are mutable, that is, you can add, update or delete values from a particular dictionary. The second element to scripting is the instructions. Instructions in Python are basically of three kinds, that is statements, built-in functions, or customized functions, that is methods. Statements are used to perform an action without returning a value in return for performing that action. Some of the most popular statements in Python are the ones listed there. Print is a statement that prints the value of a variable on console. Import can be used to import packages or libraries written by others available in your Python distribution into your current working or scripting environment. Del or delete is used to delete a particular variable. If else is a condition statement that checks for the existence of a condition with if. So if a particular condition is satisfied, it performs a particular set of actions. Else, it performs a different set of actions. For is a particular keyword used as a looping mechanism, that is to repeat a particular set of steps as per a particular condition for a finite number of times. Try except is a very elegant statement. It is used to handle system generated errors or to check for expected behavior and handle your script to respond accordingly in order to elegantly handle these errors and create a more intuitive and streamlined experience for the user. There are a lot of built-in functions that come in Python. Built-in functions, unlike statements, return a value. A few of the popular built-in functions are length, that return the length of a particular variable or its size. Max or min, that return the maximum value among a collection of values, or minimum value among the collection. Type returns the data type of a variable. So in case there's a particular variable you've worked with in multiple ways in your script and its value has changed, calling the type method on the type built-in function on that particular variable helps to know what the current data type of that particular variable is. Sum, on the other hand, returns the summation or the sum of a collection of elements, collection of numbers. I also recommend you check out this particular URL to see the list of built-in functions supported in Python version 3. This links out to the official documentation of Python, and you'll get a detailed list with description of the various built-in functions supported so that you don't have to re-implement those when you want to write your own scripts. Methods, on the other hand, are a specific kind of function that helps you perform a customized choice of actions based on your specific data or your specific object. So in case you want to perform a particular set of actions that are not supported by those built-in functions, believe me, that's going to be more often than not, you write a customized method for it. And this method, it can then be made generic enough and released to the open source community for other people to import as a program or even as a library to work with when they want to perform similar tasks. Let's now look at a quick example, a live demo which gives us an introduction to scripting in Python. We have this notebook as an ArcGIS notebook. This notebook will introduce us to both the data types and the instructions that we just looked at. Here I have a particular notebook which has already been saved to my ArcGIS environment. This notebook is also accessible for you to work with, and I'll be sharing URLs to that. We start by looking at integers. Integers, as I said, are whole numbers, positive or negative, and you define an integer by assigning the value to a variable name. Here we've defined these two integers. Multiplying two integers is as easy as using the multiplication operator on between these two integers, and as we see, it has correctly multiplied these two integers. You can check the type of a particular variable, a particular data object, by calling the type built-in function on that, and as we see, it correctly identifies integer 1 as an int. Float, as I said, is decimal numbers, decimal values, both positive or negative. Here we've defined these two floating point variables, and subtracting one number from the other, a float or integer from the other, is very easy. You can use the subtraction operator for that. As we see here, this has successfully subtracted float 2 from float 1, which essentially meant adding the two numbers. You can also redefine a particular variable by assigning a new value to it. So here we've assigned a new value to float 2, and to test if float 2 now references the new value as opposed to the old, we add these two, and as we see, it has correctly worked with the new value as opposed to the old, which is 9.35. Checking the type of a variable, as we previously saw, involves calling the type built-in function on that variable name, which returns float in this case. Also, you can add a floating point number and an integer, that is a decimal and a whole number, and it correctly returns the result as a floating point number as opposed to an integer in the interest of accuracy. Strings, as I told you, store words or sequences of characters or words within single or double quotes. Here we have two strings defined, which is Dev Summit 2021 and Python for Geographers. We print a particular variable by passing the variable name within the print built-in function, and we see it has successfully printed the value of string 1 variable. Slicing a string can be thought of as extracting portions or sections of an entire string. This is a very handy technique that can help you work with various string manipulation tasks. And in order to slice a string, you treat it as an array with indices and slice it based on the array index. So here we select all the characters within that string of index 10 and above, and we store it in this variable called new. So as we see, it has successfully sliced or extracted the last characters of interest for us, which is 2021. But we know that 2021 is a number, an integer, and not a string. So in order to convert it to an integer, you call the integer typecast on this variable, and now we see that it has converted it to an integer. To verify that, we call the type built-in function on new, and we see that now new is an integer as opposed to a string. Let's now take a look at Boolean. Boolean, as I told you, is a data type that stores one of two values, true or false. We start out by defining this variable called status with the value true. Here we'll also take a look at the if-else statements that I was talking about. So what we check for is the value of status. When you check if status or if variable, Python assumes that you're checking for that status to be true. That is, if you're checking if that Boolean variable has true, it does not assume you're checking for its status to be false. So what it does is it checks if your status is true. If yes, it sets it to false, else it prints this message. Also, outside this if-else condition statement, we separately also print the current value of the variable status. Let's execute this. So as we see, since our status had the value true, it changed it to false, and then it printed the changed value of status to false. Let's rerun this snippet to see what happens. Now, as we notice, since the value was false, it skipped this portion altogether and then executed the action steps under the else clause, where it printed nothing has changed, which essentially holds because the value of the variable, the Boolean variable, was false, and it did not change in this particular execution, and printing it, we verify that the value is still false. Let's now take a look at lists. So lists, as I told you, are an ordered collection of elements. It could be of the same or different data type, as we see here in this example, and they are mutable. So we define a particular list, and in order to access elements or work with elements of a list, you use it by accessing the index of that element within the list. So the first element has index 0, the next one has 1, and so on. So in order to access the first element, we use the 0th index, and we fetch the first element of this list, which is Python. Now, in order to access all the elements of list, we use a for loop in order to parse through that list and print all of the variables. So as we see here, for the length of the list, length is the built-in function we looked at previously that measures the length or the size of a particular data type. So for the length of this list, which is 4 elements, so for each index in this particular list, it will then print the particular element at that index. So executing this, we see that it has successfully printed all the elements of this list. List slicing, as we saw, is like slicing a particular string to access portions of it. So executing this particular snippet here gives us the second and the third element of this list right here. Deleting elements of a list is also very easy. As we mentioned, we use the del or delete keyword or the statement, and deleting the third element from this list, as we see, successfully eliminates 2021 from this list. Let's try adding an element to the list. So let's try adding 2021 again, but as an integer this time and not as a string. So adding elements to a list is as easy as calling the append method on that list object and passing in the new method, the new element. And here it has successfully added 2021, but towards the end of this list as opposed to its old position. Tuples, as I told you, are also an ordered collection of objects which are immutable, that is, which cannot be changed. We define two particular tuples here. Tuples, also similar to lists, can store values of different data types. Now we know, as we heard previously, that elements of a particular tuple cannot be deleted. Let's still try deleting a particular element from this tuple, that is the third element, and let's see what happens. Here we got a system error, a type error, saying that a tuple object doesn't support item deletion, which is something we already knew. But this presents us with a great opportunity to see how try except statements work. So here, the way try except statements work are you try a particular action, you try a particular step. In this case, it is deleting this particular tuple value, that is the third element of the tuple, as we tried previously. And we expect that this could return a particular type error. So instead of intimidating the user with a system error, we handle that error very elegantly by catching that particular error in an except clause and then printing a particular method for it, a message for it instead, right here. So this makes sure that particular system errors or expected behaviors within your script are taken care of elegantly without creating an experience which could be uncomfortable or intimidating for the user. And accessing tuple elements is similar to accessing list elements. You do it by passing the particular index. I mentioned that previously that a tuple stores write protected data, that is data that cannot be changed. This second example here, as we see, is a classic benefit of working with tuples. Coordinates of a place do not change, and you wouldn't even want to accidentally change them. So storing them as a tuple is a better choice, a better data type than storing them as a list. And right here, by accessing the latitude based on its particular index, we can print particular tuple elements. Let's look at dictionaries now. Dictionaries, as I said, are an unordered collection of key value pair elements. So right here, for this particular dictionary that we've defined, session is a key and Python for geographers is the value. Duration is the key and 1 is the value. Dictionary is also similar to lists and tuples, can store key value pairs or elements of different data types. Accessing a particular dictionary element is as easy as accessing it by its key. So by passing the key session, you can get the value, which is Python for geographers. Adding elements to dictionary is possible since dictionaries are mutable, and you can do that by adding a new key and a value associated with it. So here we add a new key value pair, which is speaker name followed by the value, which is my name. And you can verify if this dictionary has added this new key value pair by printing it. And there, as we see, it has successfully printed our new key value pair along with the original existing data. For those of us who worked with JSON or GeoJSONs, we see that dictionary in structure is identical to what a JSON or GeoJSON is. And JSON or GeoJSONs in Python can be effectively worked with using the dictionary data type. Methods, as I said, are functions we write to perform a particular customized set of actions. To define a method, you use the def keyword and then followed by the method name that you'd like to provide with parameters or inputs within parentheses. A good practice for defining methods is following it with a docstring like this. A docstring gives the user a clean and succinct explanation of what this method does. That docstring is then followed by the steps you write for, or the actions you write for the particular method. This method right here squares a number, which is x, that you're passing to the particular method. To test it, we define a particular list with 3 numbers, 3 integers, and for each number in that list, we call this particular square function with that number. And as we see, it has successfully called it and printed and returned the particular square of each of these numbers. I mentioned import as a statement that can be used to import packages or libraries written by others in order to make your experience of scripting in Python very straightforward and easy. Pandas is a very popular, well-known library that helps you work with data in a tabular format. So we start by importing pandas as its popular alias name. Not all packages have a popular alias name, but pandas does, and we follow convention and import pandas as its particular alias name that we'll be using through the rest of the script. You then read a particular CSV file in a data frame. A key advantage of working with ArcGIS notebooks is you can add files of interest that you'd like to work with within your home environment. So as we see here, I have already added browsed and uploaded a particular CSV here that I'd like to work with, and adding it to your notebook or your working environment is really easy. As we see, this particular icon here has added a reference to this particular data set, and we now read this particular data set here, this data set variable within this particular method here. So this method reads this particular file as a CSV, and it calls the read CSV method of pandas. As we see, it has read it and stored it as a data frame object or a table, and we then call the shape property of this data frame object to return the number of rows and columns of this particular table. So as we see, this table that we just added has 26 rows and 50 columns. Let's take a look at this table, the first 5 rows of this table, to see what we can fetch. So this is a massive table in terms of the attributes supported. It has information for the crashes, the street accidents in Washington DC. In case you'd like to view more than 5 rows, the default for the head function is 5. But in case you'd like to view more than 5 rows, let's say 10, we pass in that particular number as a parameter to the head method, and this has printed 10 rows instead of the default 5 for us to explore and inspect this table further. Here's a list of some popular open source Python packages for data science, data analysis, and machine learning workflows. Pandas, as we just saw, helps you load data in a tabular format and perform several Excel-style data manipulation methods. NumPy supports mathematical operations on single and multi-dimensional arrays, that is your vectors and matrices. Matplotlib and Seaborn are very popular packages for data visualization and charting. Matplotlib supports 2D charting, and Seaborn is a great package for statistical charting, as well as adding aesthetic nuances to your Matplotlib charts that we'll see shortly. SciPy is a great package that is built over NumPy. So it has the NumPy features along with additional capabilities. It allows for complex scientific computing and is greatly used in the fields of engineering and mathematics. Scikit-learn is built over SciPy, so it provides NumPy and SciPy's features along with the support for working with your machine learning workflows. So a machine learning workflow typically involves splitting your data into training, validation, and test subsets. You train your model on the training subset, and then you validate whether it works as per expectation, as per desire on your validation test. And based on the fine tuning you do back on your model, you then test it on your test subset. Scikit-learn ensures that there are elegant and simple, easy to understand and adopt methods for all of these workflows without you having to rewrite them from scratch. Again, there are several packages for performing machine learning workflows, but Scikit-learn is a great starting step. Also, other popular Python packages involve stat models, Bokeh and Plotly for visualization, and TensorFlow, PyTorch for machine learning and deep learning workflows. But this is just the tip of the iceberg and great for someone getting started. This is a list, on the other hand, for open source Python packages needed for your GIS workflows. So GeoPandas is an extension of Pandas to work with geospatial data. So as we just saw in that example previously, we read that table as a Python data frames, which would help us work with the different attributes and rows in that table. However, if you wanted to read it as a GeoPandas data frame, you would also have additional support for the XY location, so as to then work with its coordinate system and other features that come with geospatial data. Shapely is also a very powerful package that helps you create like geometry shape objects such as points, lines, polygons, and accordingly manipulate them. ArcGIS Lib is a great package to work with raster data as well as imagery analysis. GDAL is also a geospatial data abstraction library, and it encompasses two libraries. The GDAL aspect of it helps you work with raster data, and the OGR variant of it helps you work with vector data. PyShape is a very popular Python library that helps you read Esri standardized shapefiles in Python. So for any other package or library that you use that helps you seamlessly read in Esri shapefiles in Python, rest assured that it implements PyShape under the hood. PySal is also a great library that helps you perform various spatial analysis workflows on vector data. There's also a huge list of GIS specific Python libraries that you could work with. You have Folium and Fiona. You can also work with GeoDjango if you wish to build web frameworks or web applications with spatial data. There's NetworkX, Artree, etc. But again, this is just a list of the most popular libraries. Let's now take a look at this particular example, this live demo that helps you work with a lot of your GIS workflows and your data in your WebGIS. So even though I just mentioned a wide range of open source packages and libraries in Python that help you work with your GIS data and GIS needs, we'll be looking at an example only based on the ArcGIS API for Python. This library goes by the name ArcGIS, and let's just say that while all of those packages also can help you perform these workflows, using the ArcGIS API for Python has most of those packages implemented under the hood and can be thought of as a one-stop shop for your GIS analysis and geospatial data science workflows. So to get started, we first import this particular library right here. We import the GIS module of it and connect to your WebGIS that you've launched this particular notebook from. Having signed in and then created a GIS object to work with, we then import necessary packages that we need. So we import a few packages needed to work with this data and store this data as a feature layer, and we import pandas that stores this data as a table. We then look at this key step here that helps us actually read data which is hosted on the ArcGIS platform in our notebook as a particular table. We start out by defining a variable that stores the URL, which is the API endpoint for this data set. The data set we'll be working with is for aging service locations, that is aging homes in Washington DC. Once we fetch the API endpoint for this data set, we then read it in as a feature layer by passing the URL to the feature layer submodule of the library. Then we create a data frame from that feature layer and we print the shape, that is the number of rows and columns for this data set. So as we see, Washington DC has 115 different aging service locations or homes, and there are 13 different columns or attributes associated with this data. Let's also take a look at the first 5 rows by calling the head method on this table. So here's a set of different features that are made available with this data. So as this is a session for Python for geographers and we're all geographers or GIS analysts or enthusiasts, let's try to see this data on a map. To do that, we create a map view variable by calling the map method on the GIS web object, and we specify the particular extent or location we'd like for the map along with the zoom level, and we set a particular base map of choice. Having done this, having defined this, we now add the aging services feature layer as a layer to this particular map view. And scrolling down, we can see all these particular locations displayed on this particular map. Now, in order to see how charting and data visualization can be done seamlessly in Python, we use the matplotlib and seaborn library that we discussed previously. We do that to create a horizontal bar chart for the locations based on the different types of services they provide. To do that, we first look at the type column for this particular table. So for that particular column of that table, we call the value counts method on it, which gives us the total number of facilities that provide a certain type of service. We then import matplotlib and seaborn also as their aliases, and we also set color preferences of seaborn, because as I previously mentioned, seaborn has an aesthetically pleasing way of working with charting. We now try to build a horizontal bar chart with this particular counts variable that we generated right here. We do that by specifying the kind of chart, which is bar h, that is horizontal bar chart, on this particular variable. We set its x label value, that is the label on the x-axis, the label on the y-axis along with its title, and we also specify annotations, which in this case are the number of aging service values for each service type, as we see on the chart. So as we see, there are a few like aging service locations that support adult. There's only one location that supports adult education as a service, whereas there are several that support healthcare and in-home support, recreation and socialization, and most of them support group meal programs. This is a great way of visualizing and charting your data using matplotlib and seaborn in Python. Let's now fetch data for wards or a polygon file, which is a popular administrative boundary for Washington, D.C. We start out by reading the particular URL, the API endpoint URL for wards of DC, and then storing it as a feature layer, as we previously saw. We now add this particular feature layer to our map object. So as we see, now the same data set that we previously saw for just the housing locations also has the wards overlaid over it to get a sense of how many locations fall within each ward. But still, even though we know that we can eyeball and tell how many whether there are a few or a large number of aging service locations that fall within a certain ward, we can't really tell the exact number. In order to do that, we use this particular ArcGIS API for Python analysis method called summarize within. We import it from the API, and one thing I'd also like to show while we're looking at these analysis methods is that for all the different analysis that you see in your web GIS, in your map view, in order to summarize data or to enrich data or even analyze patterns, there are Python API equivalents for all of these methods that help you automate your GIS analysis workflows in Python. So we import the summarize within method here, and we provide necessary input parameters for this method. We start with the sum within layer, that is the layer within which you want to summarize data. This is the wards layer in our case. We then provide the summary layer, that is the layer you'd like to summarize, which is the aging service feature layer. And we also provide an output name for this resultant analysis layer to be stored as well within ArcGIS, within our WebGIS or ArcGIS infrastructure within the content. Once we've done this analysis and created this new summarized wards output layer, we then create a new map view object, and again for Washington DC, and we add the wards layer, this particular wards layer that we previously imported and as a feature layer in our notebook. And to that particular layer, we then overlay this particular summarized within layer that has been successfully generated. We do that and we visualize it on a new map object. So as we see right here, this gives us a quick view of which particular wards have the least or large number of aging service locations. So as we see, Ward 2 right here, has 24 different aging service locations, whereas Ward 3 just has about 8. So this is a quick way of analyzing and automating your GIS analysis workflows and visualizing them within a notebook, within ArcGIS notebooks. Let's also verify whether both our layers, that is for the wards and the analysis, are stored within this map2 object, the map view object. Having verified it, we then publish this as a particular web map. Publishing a map view as a web map is extremely straightforward. You call the save method on that particular object and provide a few mandatory input parameters such as title, snippet for the item, and tags. So as we see, performing GIS spatial analysis using the ArcGIS API for Python within the ArcGIS notebooks environment is extremely easy, straightforward, and orchestrates a very easy flow to automate your workflows using Python. I'd like to leave you with a few learning resources. W3 Schools has this great platform, this great tutorial for learning Python in an interactive way. Also, Codecademy is a great place with great Python tutorials. Also, if you'd like to dig deeper and understand Python down to its weeds to know how the language is developed and built, I strongly recommend the official docs for the Python. It not only has various constructs but also rules and best practices to build and develop with this language. For those of us who enjoy studying through books, these two books from the O'Reilly publication are great to understand Python in a very easy, straightforward, and intuitive manner. And even though we saw an example now on using the ArcGIS API for Python for working with your WebGIS objects, for those of us who want to learn ArcPy to work with our desktop GIS objects, I suggest going through the various training courses and programs we have available on the esri.com/training site. There are several courses, videos, documents available for you to learn from, not only how to work with ArcPy but several other applications that involve Python. And Esri Press also has several books that are updated regularly with more cutting edge tools that help you learn how to use ArcPy or the ArcGIS API for Python for your use cases. I did show an entire demo for the ArcGIS Python API, but I'd also like to link out the official documentation for the ArcGIS Python API. You can get started with how to install it and how to verify it has been successfully installed, along with understanding its structure as well as how it was designed. We have guides to not only understand how the API has been developed and how to get started with it. We also have examples for several workflows, even using geoprocessing tools within your Jupyter notebooks or ArcGIS notebooks. We also have sample notebooks here for you to work with. Even though we looked at one simple spatial analysis workflow, there are several examples here to do spatial, temporal analysis, as well as analysis that involve other Python libraries for your deep learning and machine learning use cases and needs. And for those of us who've already started working with this API, with this Python API, here's a link to the API reference through the documentation that helps you understand each of the different modules, sub-modules, and method signatures. And for those of us who've already dabbled with Python previously but would like to flex those muscles and as well as practice on some puzzles or popular problems, I recommend checking out this website, that's practicepython.org. It has a lot of different popular puzzles and mind-bending exercises that you can implement in Python to get proficient with the language as well as problem-solving skills. So to recap, we saw how you can get Python with Anaconda on your machine for your particular operating system. We saw the secret sauce of scripting in Python, that is, a script comprises of data types and instructions that are applied to the data stored in those different data types. We saw how you can leverage the various popular open source libraries for your data analysis, data science, as well as GIS analysis needs. We saw a great tutorial, a great demo for using the ArcGIS API for Python to do simple GIS analysis. I'd also like to leave you with a link to my GitHub, which has these slides and links to those two ArcGIS notebooks for you to work with at leisure. And another thing I hope we've learned today is that Python's really fun, really simple to learn, adopt, and work with. And I hope you have great experiences learning and working with this language. And I can't wait to hear from you on your experiences and examples. And we'd love to connect with you on GeoNet. I hope this particular session was useful and valuable for you. Thank you for taking your time from your busy day to attend this session, and we'd love to hear your feedback. I believe this particular session comes with a feedback URL, a survey link linked below. We do take your feedback, your suggestions very seriously, and we'd love to hear on how we can make this session more relevant for you and your particular needs and your particular interests that you'd like to learn with Python. Thank you for attending this session, and I hope you have a great rest of your Dev Summit.